The human story is a tale woven with curiosity. We have always been driven by a thirst for knowledge. Since the dawn of civilization, humans have been captivated by the transformative power of chemistry. Imagine alchemists in their dimly lit workshops, surrounded by bubbling potions and mystical symbols. They were on a quest to unlock the secrets of matter itself. Their ultimate goal? To discover the elixir of life, a legendary substance believed to grant immortality and turn base metals into gold. While the elixir of life remained elusive, this relentless pursuit laid the groundwork for the field we now know as chemistry. This journey took us from the mystical practices of alchemy to the cutting-edge laboratories of modern science. It is a story of incredible discovery, profound insights, and the never-ending quest to understand the world around us. The roots of chemistry run deep. They reach back to the earliest civilizations. In ancient Egypt, chemistry was intertwined with everyday life. Egyptians excelled in metallurgy. They extracted copper from its ores and crafted tools and weapons from bronze. The Egyptians also mastered the art of mummification, utilizing their knowledge of chemicals for preserving the dead. Their techniques were so advanced that many mummies remain remarkably intact even after millennia. Meanwhile, in China, alchemists experimented with a wide range of substances. They sought to create medicines and elixirs to prolong life. Their experimentation led to the development of gunpowder. This invention would later transform warfare in the centuries that followed. In India, alchemists made significant strides in metallurgy and medicine. They developed techniques for making dyes, perfumes, and even rudimentary forms of steel. The ancient world was a melting pot of chemical exploration, setting the stage for the advancements that would follow. The Islamic Golden Age, spanning roughly from the 8th to the 13th century, witnessed a flourishing of scientific thought. Islamic scholars made invaluable contributions to the world of chemistry. One towering figure of this era was Jabir ibn Hayyan, often called the father of chemistry. Jabir emphasized systematic experimentation. He stressed the importance of carefully controlled procedures in the laboratory. This emphasis on empirical observation laid a crucial foundation for the scientific method. Islamic alchemists made significant advances in distillation. They developed new apparatus and techniques for separating and purifying liquids. This expertise proved invaluable in the creation of perfumes, medicines, and alcoholic beverages. Their meticulous work laid the groundwork for modern chemical engineering and the development of sophisticated distillation techniques used in various industries today. Alchemy continued to fascinate thinkers in medieval and Renaissance Europe. European alchemists inherited knowledge from the Islamic world and added their own innovations. They were driven by a mixture of philosophical and practical goals, seeking both spiritual enlightenment and the transmutation of base metals into gold. While the quest for transmutation proved futile, European alchemists made important contributions to laboratory techniques and the study of matter. They developed new methods for extracting and purifying metals. They created new glassware for experiments. These practices, though often shrouded in secrecy and mysticism, helped pave the way for the more systematic and scientific approach to chemistry that would emerge in the 17th century. The stage was set for a revolution in how we understand the natural world. Section 5. The Birth of Modern Chemistry, Robert Boyle and the Scientific Method. The 17th century marked a turning point in the history of chemistry, a period of profound transformation and discovery. It was during this time that the transition from alchemy to modern chemistry began to take shape, laying the groundwork for future scientific advancements. One of the key figures in this transformation was Robert Boyle, an Irish chemist and physicist who is often regarded as the father of modern chemistry. His contributions were instrumental in moving away from mystical practices. Boyle challenged the prevailing Aristotelian view of the four elements: earth, air, fire, and water, which had dominated scientific thought for centuries. He proposed that matter was instead composed of tiny, indivisible particles that he called corpuscles, a revolutionary idea at the time. His groundbreaking book, The Skeptical Chemist, published in 1661, argued for a more rigorous and experimental approach to chemistry, emphasizing the importance of empirical evidence. Boyle's emphasis on observation, experimentation, and the use of quantitative data helped establish chemistry as a distinct and respected scientific discipline. His methods laid the foundation for modern scientific inquiry. His work marked a pivotal shift from the mystical and often secretive practices of alchemy toward a more rational and evidence-based understanding of the natural world. This shift was crucial in the development of modern science as we know it today. Section 6. Unveiling the Secrets of Matter, Lavoisier and the Chemical Revolution. The late 18th century witnessed a period of unprecedented discovery in chemistry, a time when the foundations of modern chemical science were being laid. This era is often referred to as the Chemical Revolution, a transformative period that reshaped our understanding of matter and its interactions. At the forefront of this revolution was the French chemist Antoine Lavoisier, often hailed as the father of modern chemistry. Lavoisier is best known for his meticulous experiments that debunked the phlogiston theory, a dominant but flawed explanation of combustion. This long-held theory attempted to explain combustion by proposing the existence of a fire-like element called phlogiston, which was believed to be released during burning. Lavoisier's experiments demonstrated that combustion actually involved the combination of a substance with oxygen from the air, fundamentally altering the scientific community's understanding of chemical reactions. His work revolutionized our understanding of chemical reactions, laying the groundwork for future discoveries in chemistry. Lavoisier is also credited with establishing the law of conservation of mass, a cornerstone of chemical science. This fundamental principle states that matter cannot be created or destroyed in a chemical reaction, only transformed from one form to another, ensuring that the total mass remains constant. His contributions extended beyond fundamental chemical principles, influencing various aspects of the field. Lavoisier also played a key role in developing a systematic method for naming chemical compounds, which brought clarity and order to the burgeoning field of chemistry. This system, which is still in use today, provided a clear and consistent way for chemists to communicate their findings, ensuring that scientific knowledge could be accurately shared and built upon. Section 7. Mendeleev's periodic table, organizing the elements. By the mid-19th century, chemists had discovered dozens of elements. However, there was no clear way to organize them or understand the relationships between them. In 1869, the Russian chemist Dmitry Mendeleev revolutionized chemistry with his creation of the periodic table. Mendeleev arranged the elements in order of increasing atomic weight. He noticed a recurring pattern in their chemical and physical properties. This led him to develop the periodic table, a groundbreaking arrangement that grouped elements with similar properties into columns and rows. The true brilliance of Mendeleev's periodic table lay in its predictive power. He left gaps in his table, where he predicted the existence of yet undiscovered elements. Amazingly, many of these predictions proved accurate. The discovery of elements like gallium, scandium, and germanium in the years following the publication of Mendeleev's table cemented its place as one of the most important tools in the history of chemistry. Section 8. The Atomic Age, Unveiling the Building Blocks of Matter. The late 19th and early 20th centuries witnessed a profound shift in our understanding of the atom. During this period, scientists embarked on a journey that would unravel the mysteries of the very fabric of matter. Scientists like J.J. Thomson, Ernest Rutherford, and Niels Bohr made groundbreaking discoveries that shattered the notion of the atom as an indivisible particle. Their work laid the groundwork for modern atomic theory. Thomson's discovery of the electron in 1897 revealed that atoms were composed of even smaller, electrically charged particles. This was a monumental step forward in our understanding of atomic structure. Rutherford's gold foil experiment in 1911 led to the discovery of the atomic nucleus. This experiment demonstrated that atoms have a small, dense core. This tiny, dense region at the center of the atom contains positively charged protons and neutral neutrons. It fundamentally changed our understanding of atomic structure. Bohr's model of the atom, proposed in 1913, introduced the idea of electrons orbiting the nucleus in specific energy levels or shells. This model provided a clearer picture of atomic behavior. This model helped explain the behavior of atoms in chemical reactions and their interactions with light. It was a significant advancement in the field of atomic physics. These discoveries laid the foundation for the development of quantum mechanics, a revolutionary theory that governs the behavior of matter at the atomic and subatomic levels. Quantum mechanics has since become a cornerstone of modern physics. This new understanding of the atom opened up a new era in chemistry, the era of nuclear chemistry. It paved the way for numerous technological advancements and a deeper comprehension of the natural world.